More than 40,000 American soldiers are estimated to have vanished at sea since as far back as World War II and subsequent conflicts, and their remains are believed to be buried near wreckage of ships and fighter jets at the bottom of the ocean floor. For decades, U.S. authorities have made several attempts to retrieve the remains of these fallen soldiers. They called it the silent loss. CNN reports, says, more than 40,000 American soldiers, airmen, and sailors vanished at sea during World War II and later conflicts. Their bodies never recovered. Their names etched in memorial walls, but not in graves. They rest, scientists say, among the twisted skeletons of planes and ships that sank to the ocean floor. A submerged graveyard stretching from the Pacific to the Mediterranean. For decades, their disappearance was treated as a tragic inevitability of war. But today, new science is challenging that finality. Using groundbreaking DNA detection technologies, researchers are trying to bring these soldiers home. Not by bones or dog tags, but through invisible traces of genetic memory preserved in the sea itself. This is the story of how science, history, and duty are converging in a race against time and tide to solve one of America's greatest wartime mysteries: how 40,000 heroes vanished beneath the waves. In the shallow blue waters of Saipan's harbor, a coral-encrusted warplane lies upside down, a Grumman TBF Avenger, its once deadly machine guns now home to fish and coral. The aircraft went down during the 1944 Battle of Saipan, when U.S. forces fought to wrest control of the Northern Mariana Islands from Japan. 3 crewmen were aboard. Only one survived. The others remain missing, but not forgotten. Today, that wreckage has become a test site for HOPE scientists from the Woods Hole Oceanographic Institution and the Defense POWMIA Accounting Agency are experimenting with a revolutionary idea. Could microscopic traces of human DNA still cling to the sediments around the wreck? Could the sea itself remember the men it swallowed? The Avenger, once a weapon of war, has become a laboratory of remembrance, the first battlefield in a new scientific front. Traditional underwater recovery missions are notoriously difficult. Unlike land excavations, oceanic searches face darkness, shifting sediments, and vast uncharted expanses. Wrecks are hard to locate, and even when found, human remains are often scattered or buried deep within coral and silt. That's where environmental DNA comes in, a technology that detects genetic material shed by living or dead organisms. Every human releases DNA into their surroundings through skin, fluids, or decay. In theory, even decades after death, fragments of this DNA could linger in the ocean floor's sediments. Dr. Kirsten Meyer-Kaiser, a marine biologist at WHOI, calls it the bone sniffer. Using this technique, researchers can test water and sediment samples for fragments of human DNA without disturbing the wrecks. It's a method once used to track invasive frogs in France, now turned towards solving wartime mysteries. If successful, it could transform underwater archaeology and offer long-awaited closure to thousands of families still waiting for a knock that never came. The project's scope is vast. 12 wrecks were examined, from Saipan's tropical lagoon to the cold freshwater depths of Lake Huron, and even the Mediterranean coast near Palermo, Italy. Each environment presented unique challenges: saltwater corrosion, unpredictable currents, and the relentless decay of biological matter. Divers like Calvin Myers, a maritime archaeologist, descended to collect samples, not bones, but traces of presence. Equipped with sterilized tools and Niskin bottles to capture water, they worked cautiously to avoid contamination. Even their own DNA was sequenced beforehand to prevent false positives. After collection, the samples were shipped under strict frozen conditions to the University of Wisconsin Biotechnology Center. There, scientists used a technique called metagenomic sequencing, analyzing every strand of DNA in the samples to separate the ancient from the modern. They weren't just searching for the soldiers' remains, They were searching for proof of concept that the sea can indeed remember. When the data finally came in, it brought both hope and confusion. Among the sediment samples, researchers found human DNA fragments as short as 40 base pairs, a telltale sign of long-degraded genetic material. These tiny strands hinted at decades-old origins, possibly belonging to those lost during the war. In contrast, longer fragments, over 150 base pairs, indicated modern contamination, perhaps from divers or tourists. But even with this progress, the puzzle remained maddeningly incomplete. Curiously, control sites, areas with no known wrecks or remains, sometimes showed higher concentrations of old DNA than the suspected crash zones. Could the ocean be saturated with the genetic echoes of humanity? Or were ancient traces drifting through currents, preserved by minerals, as some scientists theorize? Dr. Elena Irene Zavala, a forensic geneticist in Copenhagen, suggests that DNA can bind to sediments and persist for thousands of years. But in the ocean, where temperature, salinity, and motion vary wildly, predicting its survival is almost impossible. Still, what Meyer-Kaiser's team achieved was groundbreaking: the detection and differentiation of ancient human DNA in open sea environments, something never before done at this scale. Despite the progress, no actual remains have yet been recovered from these DNA-positive sites. The researchers urge follow-up excavations to confirm whether these signals truly mark the final resting places of missing soldiers. The DPAA, meanwhile, is cautious. Dr. Jesse Stephen, the agency's chief of innovation, emphasizes that eDNA is not a shortcut, but a new tool, a way to map probability before digging. The method won't identify individuals, but it could pinpoint where to look, saving years of blind searching. The implications reach far beyond science. For families who have lived generations without closure, even the possibility of recovery offers a form of peace. For the military, it represents a sacred promise that no soldier, no matter how long lost, will be forgotten. Other pilot projects are now underway, combining underwater drones, machine learning, and microbial forensics, all aimed at reading the ocean's hidden archives step by step. Humanity is learning to listen to the silent testimonies buried beneath the waves. The ocean does not easily surrender its secrets. Yet, through science and devotion, fragments of forgotten lives are resurfacing, not as bones or relics, but as whispers of DNA, lingering in the dark. Each test tube of sediment, each sequence of base pairs, carries a message from history, a reminder of courage, sacrifice, and loss. The sea that once devoured 40,000 American soldiers may now help restore their stories, turning silence into remembrance. Dr. Meyer-Kaiser calls this mission the intersection of grief and innovation. It is, at its heart, not just a scientific experiment, but a moral voyage, one that bridges the living and the dead, the past and the present. As technology advances, the dream of bringing these fallen heroes home grows closer. Perhaps someday, in the quiet of a lab far from the roar of war, the invisible will become visible again, and the names once lost to the deep will be spoken aloud, one by one. For now, the ocean keeps them, but it no longer keeps them alone. 80 years after the guns of World War II fell silent, the ocean remains America's largest unmarked grave. Beneath its shifting tides lie more than 40,000 souls, men who fought for freedom and vanished without farewell. For decades, they were simply missing. But through today's remarkable advances in environmental DNA research, that word no longer feels final. What the scientists of WHOI and the DPAA have proven is not just a proof of concept, but a proof of commitment, that the promise to bring every soldier home still stands, even when their bodies are dust and their names nearly erased by time. Each sequence of degraded DNA recovered from coral, sediment, or water represents a faint echo of life and an act of remembrance. The story of the vanished soldiers is therefore no longer only one of loss, but of continuing discovery. The sea, once a vast and merciless graveyard, is slowly being transformed into a source of truth. These studies remind us that technology is not only for progress, but for atonement, for finishing the unfinished business of history. If the ocean truly holds the memory of every man it has taken, then our responsibility is to keep listening, patiently, humbly, and with the same courage those men showed when they sailed into the unknown. Because someday soon, when the last trace of DNA is matched, when science and duty converge, those who vanished may finally come home, not as ghosts, but as names restored to the living world they helped to save.